Alright, so this is drawing quantitative force diagrams. Now, what that means is that we're actually going ahead and we're going to be drawing force diagrams, okay, these free body diagrams. But now we're going to be doing so, okay, when we're actually going to be writing in not only what the forces are, like force of gravity, force normal, let's say that's force applied, force of friction acting against it. We're not only going to be doing this, but now we're actually assigning values to that, okay? But one of the major assumptions that we're going to do in order to do this quantitatively is to actually know that if an object is moving at a constant velocity or it's at rest, then the acceleration is 0. Okay? Basically what that means is that if the acceleration is 0, then so is our unbalanced force, our net force, or the sum of all forces, depending on how you look at this. Again, this is just simply put Newton's second law, Fu is equal to ma. If acceleration is 0, then that means our net force is 0, or our unbalanced force. Okay. Moreover, and I'm going to come back to this as we work through it, but if I know that the sum of all my forces are 0, then I can break it down even more simple, and I can say all of my x forces add up to 0. All of my y forces add up to 0. Or I can even put it better yet, that my forces that act in the left will be opposite and equal to all the forces that act in the right. Forces up will be balanced by the forces down. Okay, I guess the best way to explain this in more detail is to just give you guys a couple examples. Okay, so here I have an object, and again I'm just going to go ahead and draw the force diagram of this. Okay, the first thing that I can definitely do is say that it has the force of gravity acting upon it. The next thing I know right away is that there are two strings adding tension. I'm going to call that force of tension 1. And then I have this other string, force of tension 2, we'll call it. Okay. Now again, this object is not moving. Okay, I can assume so much because of the way that it's drawn and how it's written up here. So if it's not moving, that means then that the sum of all the forces are 0, which means the forces in the x add up to 0, the forces in the y add up to 0. Okay. Now I'm just going to go ahead and I'm going to keep looking at this. And first thing, I'm going to break this down. Okay, that angle is going to give me, eventually using trig, I can find ft1 in the x direction and ft1 in the y direction. Okay, and these are essentially my forces. Now, let's say I had numbers and I broke these down, which I could do. That no longer makes ft relevant because I have it x and y. Okay, now I can say this, I can look at this qualitatively and say, well, Ft2 is going to be balanced by the force of tension of the vertical component here, or the horizontal component. So I could say that this is balanced by that, because I know it's not moving. And again, I can reiterate this by my x forces, or I can say my force left will be equal to my force right, which also means that my force of tension 2, this one is a leftward force, is going to be equal to the force of tension 1 in the x direction. Okay. Those two are equal and opposite. Now the other two that are equal and opposite are my force of gravity and my force of tension in the y. Okay, and again I can say that by force up will be equal to my force down. My force up is force of tension 1 in the y. My force down is the force of gravity. Okay, again all of this is able to be told true based off of that. The sum of all the forces is 0 because this object is not accelerating. Another example we'll go over. Let's say, for example, we'll do this one first. Okay, I want to know what all of the forces acting on this object are. Okay, well first, always draw a diagram. And I know there's a force of gravity acting on it. I know that there's a normal force acting on it because it's sitting on a surface. I also know there's a force applied, which we're told, and that's at this 30-degree angle. Force applied in the x, force applied in the y. And then lastly, we're told this. Okay? And the fact that we're told that means that there has to be friction acting against it. Again, we're pulling the x. Okay, these are all going to balance each other out. Since we're at a constant velocity, we know that friction is acting here. Okay? So this question is asking me to find the normal force if this object is applied by a 100 Newton force, so I can put that in right away. Okay. I also know the force of gravity, which is 20 kilograms. Again, force of gravity is mass times gravity, which is 20 times 9.8. So I'm going to do that on my calculator real quick. 20 times 9.8 gives me 196. So the force of gravity is 196. Now the common tendency here is for people to say, okay, well, 196, that means that my normal force is 196. Can't do that here. Okay, we also know that this is a y force, and the force normal is a y force. So we can't blindly say that they add up together. Instead, we're going to have to do some trig here with my triangle. Okay. Now again, we should be pretty comfortable with doing this at this point, but nonetheless, we'll talk you through it. I have my hypotenuse. I want my force applied in the x direction first. So adjacent hypotenuse, I'm going to go cosine of 30 times 100 will give me my force applied in the x. Okay, again, cutting some corners here because I know we're familiar with this. So cosine of 30 times 100 should give us 86.6 newtons. Okay, my force applied in the y is going to be sine of 30 times 100. My force applied in the y is 50 newtons. Okay, now this question is asking me to solve for my normal force. Okay, in order to do so, I need to understand that all of these forces are going to add up to 0 because acceleration is 0. It told us constant velocity. So based off of this premise, I can then say that the sum of all my forces in the y direction will be 0, or I can even break this up further and say that my forces up are going to equal to all of my forces down. And then I'm going to look at this and say, okay, forces up. I have my force normal, I have my force applied in the y, and that's going to be equal to my force of gravity. Okay, now we can substitute the values in that I currently have. So 196 was my force of gravity. That's going to be equal to my force applied in the y, 50. My force normal then is going to be this number. Okay, I'm going to subtract 50 from both sides. And we should come up with 146 for my normal force. Okay, so it's not always as simple as just saying force of gravity is equal to the normal force. But again, when we're told that there's a constant velocity, acceleration is 0, anything like that, that means that this thing is at equilibrium, which means all of the forces are balanced. And we can come back to this blind statement that I gave you guys at the very beginning. Okay, remember this. This is huge. If velocity is constant, or it's 0, that means acceleration is also 0. If acceleration is 0, so is our unbalanced force, our net force, or our sum of all of our forces, which lets us make these assumptions to help us solve for these problems. Hopefully that helps you guys study how to qualitatively and quantitatively draw your force diagrams. Again, though, if anything needed.